This is lesson 18, multiplying three factors and then missing factors. So multiply, remember, factor is numbers multiplied together. So multiplying three factors is really easy because you just do two at the time. That's all that is. However, sometimes it's helpful to pick the ones that you want to multiply. Remember, I can use the commutative property to move these around. So I want to see if I can find two of these that end in a multiple of 10. So 6 times 3 is 18. 18 times 5 sounds kind of hard, doesn't it? What if I did 6 times 5 and do that first because it ends in a 0, a multiple of 10. So I'm going to say, oh, 6 times 5 is 30. And then 30 times 3 is 90. So that's easy, right? Make it easier on yourself. Let's do another one. 5 times 7 times 12. Remember, I want a multiple of 10. So if you know your 12 times tables, you know that's a 12, even though it doesn't look like it. 5 times 12 is 60. So note that that's a multiple of 10. And now I can just do 6 times 7 is 42. So 60 times 7 is 420, right? So that's pretty easy. Example 3, we're going to do in the book because I didn't draw it out. Let's see. Okay, how many blocks were used to build this shape? So blocks are kind of hard. I know that there's 3 on this side and 2 on that side. So there's also 3 on the other side. So the whole thing about the bottom row. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So I know it's going to be my answer. How many are on this top row? So look at the top layer. Can I see 6 blocks? 1, 2, 3, 4, 5, 6. And it's a solid figure, so I know there are also 6 blocks on the bottom, right? So 2 times 3 times 2, or 2 times 6, right? So I have 2 columns, 2 rows of 3 in each row. So that would be your 6. And then your next layer is 12. I'm not very spatially aware. That part I can see. When it gets a lot more complicated than that, I struggle. So maybe some of you guys too. It helps if you can look at the top and think about what's underneath. That's always a good hint for me. Okay, example 4, they give you a couple just problems to work on. So something times 3 is 18. Go back to what you know. Think, something times 2 is 6. Well, I know it's 3. How did I get it? Oh, 6 divided by 2, right? So could I do 18 divided by 3 and get 6? Sure. Okay. This is where fact families come in handy. So I know that something times 3 is 18. You might just know 6 times 3. So you could just do 6 instead of dividing when they're easy like this. Oh, could you see that? Probably not. So, I don't know, maybe. So, something times 3 is 18. 6 times 3 is 18. Okay, I think I got a little carried away pushing it forward. 3n equals 24. Do you guys know what that means, that n? So, anytime you have a letter bumped up against a number, it means you're going to multiply them. So that 3n equals 24 is the same thing as 3 times n equals 24. Well, 3 times something is 24. So I know that it's 8. But I could say 24 divided by 3 is 8 and still get my unknown answer, right? C is a little trickier because they give you 4 terms, right? And they say 6 times 5 is the same thing or equals 3 times w. I mean, why? Let's do this first. Let's simplify. So I'm going to change that 6 times 5 to 30. And I know 30 equals 3 times y. Okay. Well, 3 times y equals 30. Can I swap places so that it looks more familiar to you? You don't have to. You can do it this way. Some of you, it gets you a little confused if there's more than one thing on the right side of the problem, so it doesn't matter. You can swap. And then I'm going to say 3 times something equals 30. So 3 times 10. I could also say 30 divided by 3 is 10. So I know that y equals 10. Okay. Okay, so this gets a little bit harder with missing numbers. Make sure and check your work. Make sure it makes sense. It's a reasonable answer. And that's going to be very helpful to you. Good luck.